The Brown family purchased the house worth $210. The value of the house is expected to increase by 4% per year. Remember, my suggestion for word problems is always read it once, then the second time try to figure out what is the question and what information can I pull from the actual content. So we are expected to write an exponential function where y is the value of the home and x represents how many years, after how many years. Y is the value, so y is in terms of money, and x is in terms of years. Okay, so remember with this we have, and these are my own little initials, but we have the total, and then we have, you can use a sub 1, or I'm just going to say the initial amount. You have your rate, here, and then you have how often does that occur, and remember this number will always correspond to the total. So what do we have here? We know the initial amount is $210,000. And it says it's going to increase by 4%. Now, this is the part that often confuses students. And part of the reason it confuses students is people want to put a 4, or they want to put a 0.04 as they put it as a decimal. Remember, it's always the baseline is 100%. Increase means to add, so I want to add 4% to 100% to get 104%. As a decimal, it's 1.04. Now, when does it occur? It occurs per year, once per year. So 1's on the bottom. In this case, it says y is the total value and x is the number of years. So is this acceptable? Sure. Or x divided by 1 is just x. Now, in the past, I've had students that have done this, but they've put the x when they write it out on their answer. They've put it at, and I'm going to do this wrong, they put it at the same level as the 1.04. Remember, this is an exponent. Make sure that it is up above as an exponent. So this is the equation. Now, if we assume that the value of the house continues to increase at the same rate of 4% per year, the next question is, how much will this house be worth after 10 years of ownership? So after 10 years of ownership, what will it be worth? And that's what this equation does. It allows us to predict, if we assume it's going to continue to increase at the same rate, it allows us to say, hey, how much will my house be worth in 5 years, or in 10 years, or in 15 years? So to do that, I get to simply plug in 10. And remember that when we do this, we follow PEMDAS. First we take care of this, and then we multiply it by the number out front. So I can just simply go into the Desmos calculator, the very basic Desmos calculator, and I'm going to type in 210,000, and I'm going to take it to the 1.04, and I'm going to raise that to, so a to the b, raise it to the 10th. All right. Now, it is also important to see what kind of answer are we getting, So if I was going to do it, I would round it just like money. I'd round it to the nearest cent. So $310,851, and I'm going to round that to 30 cents, here. Why 30 cents? Because if I can go over here and you guys can see this, this would be, again, we look at 29 cents, we look at the number behind it to decide does it round up or stay the same. So if I bump back here to this portion, this is what we can predict that it would be worth after 10 years. Look at the amount of money. Look at the amount of money that we gained in this. This is a lot of money that we've gained. The graph you're looking at depicts the value of a stock. We can see the starting value of a stock is 15,000, and we can see what happens over the course of 1, 2, 3 years. This should match up with 2. We don't have an exact value for 3, but we can see that it's going down. Now, we're told that this is exponential, and we're asked to write an exponential function where y is the value of the stock and x represents after so many years. So we're asked to use x and y. So we're going to start again with what do we know. And so I'm going to show you 2 different ways to do this. Now, we could come up with ordered pairs, like I know that after year 1, it's at 10,500. After year 2, it's at 7,350, and it starts at 15,000. And we learned last week how to actually algebraically come up with the 2 equations and combine them in order to solve. But today, I'm going to teach you a shortcut. Now, according to the standard, I'm supposed to be able to grade you on the algebraic. The rubric says algebraically, but within the test and it being virtual, remember, I can't see your work. So I want to teach you a shortcut to doing this. And so you're going to pay close attention here. I'm going to go back here. I'm not going to go to the basic desmos. I'm going to come up here and I'm going to Google. And it's going to be exponential regression calculator desmos. You may want to type that in as well. Exponential regression calculator desmos. And so I'm going to click on the first link we see. And now here's the thing. If I can show you at the top before I even get started with anything. There's three different equations. There's the black equation. They call this y sub 1. It's one equation. And then there's y sub 2 and there's y sub 3. There's no more than y sub 3. But in order for us to turn these off, because we're only going to be doing one equation, the only equation that we are going to model is we want to come up with an equation simply of this. We don't need to compare it to any other equation. So to do that, what I'm going to do is I want to turn this off. So when you click on this, it turns it off. Now, I'm only working with these two. Now, I don't want those numbers. I wish there was a way for Desmos to present us with something similar to this, but it would already be clear. So what I do need to do is I'm going to highlight it. And once I highlight the first one, I just keep going down. I'm just going to go down, and each time I click the arrow going down to the next, and I'm just going to clear them. So there's no need to clear out the y sub 2 or the y sub 3, because by clicking it off, it's like it doesn't even exist. Okay, so what am I going to type in here? Well, if I come back here so it's a little bit easier for you to understand, remember we have x and y, right? But when we do our charts, this represents the cost of the stock, and this is after so many years. Remember, we always do the independent first and dependent second. So 0 years, it's initially worth 15,000. Year 1, it is 10,500, and year 2 is 7,350. This is what I'm going to plug in, and I'm going to use this regression model to plot the points. Not only plot them, and then it'll take like the average of those points to come up with an equation. So 0, 1, and 2, and 15,000, 10,500, and 7350. Okay, so I only want this. Now here's the deal. Just like there's all this extra jazz over here, I'm going to start to delete things. The only one I want is the red one. That's the first one. We can see that's an exponential. Everything else I click off of. So I click, just keep clicking. That's the only thing that I want. And again, I wish that there's a way for me as an educator to give feedback. Okay, we got it. So I've clicked everything else down. So I only have one thing here, and I have to click on log mode. You want to maybe put that in your notes. All right, so I have the information here, and down below it actually takes those points. It takes those points, takes the average of them, and it creates an equation. So like if I went like this, I could see exactly where that crosses the 15,000 way up there, right? Way up there. And so this is the equation. You're like, well, how do I write this? See how A is the first number, 15,000. B is what we normally write as an R, is 0.7 raised to the x. So over here I can come back and I can write down y equals 15,000, 0.7 raised to the x. This describes, it models this curve. And that makes sense because look at the number up front is positive, and because 0.7 is between 0 and 1, we know it's decay. Decay from left to right is going to decrease. From left to right, it decreases. All right, now here's a tough one. If this describes a particular stock, the question next is, this stock is losing what % of its value each year? This stock is losing what % of its value each year? Okay, really commonly missed question. And then when we go back, it's like one of those things where kids are like, oh, I get it. Okay, so most students say it's losing 70%. But remember, if we go back to the previous problem and we think about this, It was 100%, that's always our baseline, increased by, now it told us actually in this problem, it was increased by 4% equals 104%, right? Then we turned it into a decimal. Then we turned it into a decimal to get this. So it was 100, what did I do? Plus, because it was increased by, it actually gave me the percentage, and then we got the final amount and put it into a decimal. Over here, it's slightly different. Here, we can see that, remember, 100% is always the baseline, so I'm going to put down 100%. And I know it's decreasing because this is less than 100%, right? This written as a percentage is 70%. If you take this decimal, move it 2 places to the right, it'd be 70%. This is my end product. Just like 104%, 1.04 is the end product. This is my end product. So I know that 100% subtract some number is going to equal 70%. 100 subtract what gives you 70%? Well, think of it in dollars if percent's confusing. $100 subtract how many dollars gives you 70? And the answer is 30. This stock is losing 30% of its value each year. I would like you to practice a very similar problem. This graph represents the value of the stock, and I would like you to write an exponential function where y represents the value after x number of years, just like we did in the last equation, and then I want you to determine the stock is losing what percent of its value after each year. I'd like you to press pause on this, do the work, then come back and press play to this video, and we will go over how to get the answer. First thing I'm going to do is I'm going to look at this as a table. Again, this is years after you have the stock. This is the value of the stock. So the initial year when you first buy it, it's worth $2,000. After year 1 and after year 2. Now I'm going to close out so you have an idea how to find this and what it looks like. So what you're going to do is you're just going to open up a new window and type in exponential regression calculator and desmos. It's the first one. And like I said with the previous problem, I really wish we could make this a little bit neater. It'd be less work. I'm going to take the last two, I'm just going to cross them out. Okay, so now they've been like blacked out. If you come down below, we only want the first one, so everything else you can X out. Everything else you can X out, so it's only that first equation. All these additional equations that I'm Xing out would have attached to the other equations that I have excluded, okay? Then I'm going to come back to these two. I'm going to highlight the first, and then I'm just going to hit backspace or delete, and then I just use the arrow to keep going up. Delete everything here. There's no need to delete the information or data from the other points because we're not using it. Now, X is the number of years since having the stock, and Y is the value of that particular point. And now, if I do need to add one thing that I forgot to do last time. This is important too. You need to click on this, okay? You need to click this. So click on where it says log mode, all right? So click on where it says log mode. For this particular problem, because it's a nice streamlined problem, it's not going to impact anything, but it could for the future. So click where it says log mode, please put that down in your notes. And now what does this mean? This is your initial amount, and this is your rate per year. So I'm going to write this down. The value of a stock begins with 2,000, 0.6 is your rate, and this is after X number of years. Now the second question that was the most confusing for students is the stock is losing its value each year by how much percent? Remember, it is not 6%, it is not 60. First turn this into a percentage. So 1, 2, 60% really is what's on the inside. Okay, so I know the baseline, which is 100%, and because this equation is because it's going down, I know that there's two reasons I know this is exponential decay. One is the shape of the curve. Second is this number is between 0 to 1. So if it's decay, I am subtracting and going down. 100% subtract some unknown percent gives me a final answer of 60%. So what are you taking away from 100% to get 60%? Now, could I subtract 100 and then divide by -1? Sure, I could. Or many of us will just go, okay, 100% minus 40%. So the answer is you are losing 40% of its value every year. Every year we're going down by 40%. This particular problem says to use a graphing calculator. Well, the district test is going to say use a graphing calculator. We know that we don't have graphing calculators, and most of us don't have a graphing calculator that's easy and accessible to us right now. But the desmos calculator works in the exact same way. So again, don't be intimidated or freaked out when it says use a graphing calculator and you're thinking, I don't have one. So directions would be use a graphing calculator to calculate the exponential regression model to fit the data. So basically what's happening is that in the program we're going to go into, it's going to plot all these points. It's going to go 0, 7.2, 2, 8.712, 5, so on, 7, and 10. And then it's going to make that curve that's the average of those points. And that's just what we did actually with the last two problems with the value of stock. So how do we plug it in? Again, and I'm going to come back here, and I'm going to pretend like we didn't have that, just so we can go over this one more time. And so again, we're going to do exponential regression calculator. Go back over there. I want to make sure that I have pressed play here. It is going, just to make sure. Okay, again, I'm going to click off of the second one, and I do have to use the arrow to get to the third. Click off of that. Then I'm going to come back here, and I'm just going to erase everything. So I do have to highlight it first, and then I click either delete or the backspace, and I just use the arrow to go up and delete everything from the first x and y. I'm going to come down below, and I only want that first equation. So there's the first one. Everything else I'm going to get rid of. It states that this is exponential, and when I look at that first equation, I know it's exponential, like Eric shared with us yesterday, because the variable is in the exponent position. So I'm going to come back up here, and I'm simply going to take the random points that's given to me, and I'm going to plug them in accordingly. Now, I have had students in the past say, well, can I round when I'm plugging them in? No. So 7.2, 8.712, 15.596, 14.031, and 18.675. So I can see that extra. Look in here, I can see it's actually graphed the points, and then it makes a curve. It doesn't do like connect the dots, it makes the average of them. Now here's the cool part. Excuse me, I'm going to go back so you can see it. If I come down below here, remember I have to hit log mode. Maybe put a little asterisk in your notes as a reminder you need to hit log mode. This is what I'm going to write down. This is what I'm going to write down right here. Okay, and I do want to check. It does say round to the nearest hundredth in our answers. The nearest hundredth is the second place past the decimal. So I would look at this 0, and then I look behind it. It's another 0, which says it doesn't round up. So I have y equals 7.20 times 1.1 raised to the x. As a reminder, hundredth means you go to the second place and then sneak behind it and look. If the number behind it is a 5 or above, we round up. If not, we keep it the same. So this is the equation. This is the equation. Next is we're going to answer each one of these questions, and if we have an ugly decimal answer, which is very possible, we're going to round to the nearest hundredth. So the first one says predict the y. So you don't know the y, but what you do know is you know the x is 12. So I get to come back to the graph here. And would there be a way to do this algebraically? Sure, but we can save a lot of time just simply using the graph. So we know x is 12. Give me 1 second here. I have somebody joining us late. Okay, so I'm going to come up here. Again, I know x is 12 because that's what the problem says. It says, what's the y when you know x is 12? You know x is 12. So I come up here and I simply type in x equals 12. Now I go to exactly where they cross. I go over the top of it. There will be a point. Okay, so when x is 12, y is 22.597. This is a great example. I'm going to write this down of where we can talk about rounding. So I'm going to write down the ordered pair first of all. And then I want you right now, as I get ready to do this, I want you quickly, you have 5 seconds, I want you to give me a y value rounded to the nearest hundredth. Go. This is the hundredth. so I'm at 59. But when I look in back of it, the number in back of it is greater than 5, which means I need to bump the 9 up. Well, when the 9 bumps up, it becomes not 59, but 60. So my y value that I would type in if this was an actual test would be 22.60 because the 59 bumps up. Okay, going on to the next one. The next one says predict the x value when y is 10. So I'm going to come back to the graph. Same concept, and this time I'm typing in y equals 10. Y equals 10. I find exactly where they cross. I'm going to write it down. Remember to round to the nearest hundredth. It does say that. So I come back over here. I look at the 4. I look behind it. It says bump up. So the x value would be 3.45. This would be the y value previously, and this would be the x value. Sticker problem says, given this, evaluate it. So when you're going to evaluate it, you could pull out that chart. You could pull out the chart that has all of the tables, or remember we do have a function within Desmos that can do it for us. So I'm going to demonstrate how to do that. So I go just to the normal Desmos graphing calculator. You're going to find the term when you come up here to the keyboard that says function. Function's way over here, and then you're going to find miscellaneous, abbreviation for miscellaneous. You do have to click on it. And then down below is log base A. Now for the problem we just did, a reminder that it's base 2 of 1 over 32. Base 2 of 1 over 32. So this becomes a 2, and this is 1 divided by 32. The answer is -5. That's all I have to do. So you're wondering, what do I put for an answer? It says to evaluate it. You're simply typing in -5. Again, another example. We could either choose to use the table to answer this. Maybe some of you even already have the skill set to know groups of 5, what this would be. Or what we could do is we can come over here. I do want to clear this just to show you the steps again. So it may look like this when you open up Desmos. You're going to click on the keyboard, go over to function, make sure miscellaneous is highlighted, and then down to log base A. So this particular problem is base 5. And you're using the arrows to get inside the parentheses of 1 divided by 125. So this particular answer, when evaluating this expression, is -3. Okay, now we're going to take each one of these and we're going to use the answers. So I have an answer here. We're going to rewrite this in exponential form. This is log form. So if it seems a little confusing because I circled it, here is one statement. This is a correct statement. That's one statement, and here's the next one. This is in logarithmic form, right? This is in log form. Now we're going to rewrite this in exponential form. How do we do that? Remember, this is always, you need to write this down, this is always the base, this is always the exponent, and this is the answer. So, 2 raised to the -5 equals 1 over 32. Can you put this in parentheses? If you like to. 5 raised to the -3 equals 1 over 125. And if you want to make sure you did it right, go into the Desmos calculator, type in 2 to the -5, and you better get this answer. Type in 5 to the -3, and you better get this answer. Similarly, this is the base, this is the answer, this is the exponent, right? But this is logarithmic form. So if a question asks you to rewrite this equation in an equivalent exponential form, remember this is log form, logarithmic form, what does exponential look like? Always base, exponent, answer. Base, exponent, answer. One more. Base, exponent. We're going to practice several problems where we are going to identify the inverse of a function. Remember, for identifying the inverse, there's a couple steps that we've learned how to do, dating back to how do you do we went over it this quarter, how do you find the inverse of a linear, of a quadratic, of a radical. Remember, the first thing is, if you don't see a y, I'm just going to switch this right now to a y. It'll just make it easier. Okay, so that's first of all. If you don't see a y, put a y there. And now the next thing is we're going to switch the x and y. And then we have to find a way to isolate this, okay? Now, I will talk about some mistakes kids have made in the past. They think, okay, it's like stuck with this, so I'm going to divide by log base 3. Can't do that. Or they think, I'm just going to subtract the 1. Can't do that either. What we're going to do is something that we learned earlier this week. We learned about inverse properties, and you practiced some problems like it on the homework. Whatever this base is, this particular number, this now becomes the base, and this whole thing is the exponent. And remember, whatever you do to one side, you must also do it to the opposite side so the equation stays balanced. Again, how did I choose this number? It's this number right here. This is now the base, this whole thing is the exponent. This is the base, this is the exponent. And if you're wondering why did you do that, it's a great question. The reason for that is remember that when this number is the same as the log of the base of top, they don't just disappear. It turns into a 1 and we get to bring this down. Whatever's in back of it. Now, when I distribute by that 1, it doesn't do anything. And the very last step to isolate the y is to subtract the 1 to the opposite side. Now, notice that the 1 is not going to be up top in the exponent. It's at the same level as the 3. That is important. And lastly, it is very important that we use inverse notation. That means that we need to denote this as the inverse of this. So I come back up here. And to show that this is the inverse, I'm going to write it down, to show that this is the inverse, I don't leave it exactly as the same. Inverse is denoted with this little negative 1. So I'm not going to leave it as a y. I go back to the original, so it's g of x, but it's the inverse of g. If I would graph these two, remember they would reflect across the line y equals x. Remember that the coordinates of the xy here would just flip and become the coordinates over here in y and x. Okay, we're going to try another one like this. Let's do h of x this time. And I would like you, if you felt confident, to press pause, do the work, press pause, do the work, then press play to see if it matches what I'm doing. Okay, I'm going to switch this to a y. And then I'm going to switch the x and y. Let's isolate this. I take whatever this base is, and now it becomes the base and the exponent. The base and the exponent. Whatever I do to one side, I must do it to the other side. The reason I did that is because when simplified, this becomes a 1, and I get to bring down what was behind it. Common mistake is people want to write 7x. No, it's 7 raised to the x. When you distribute a 1, nothing changes on the right. And now I'm going to add 4 to the opposite side. They can't be combined. And this is not part of the exponent. Now this alone, I'd be able to give you like half credit. You did all that work. It does remind you need to write this in inverse notation. So I go back up to the top. I denote it as the inverse of this original h of x function, and then I write it down. Final opportunity, please find the inverse of this function. Press pause, do the work. Rewrote the f of x as a y, switch the x and a y. Now I take whatever this base is and write it as the base on both sides. It becomes the exponent and the exponent. 1, bring down the y plus 5 for this problem. Distributing does not change anything on the right. 2 raised to the x. Now when I bring that 5 over, subtract 5 equals y. This alone won't be the answer. Remember, it does remind you to write it correctly in inverse notation, which means make this little original function as f of x, denoted with a negative 1, is 2 raised to the x minus 5. This problem you're asked to solve for x. If you remember doing this and you feel pretty confident, again, press pause, do the work, and then press play to see if you did it correctly. If not, I'm going to start right now, and you're welcome to work through this with me. So I'm looking at 25 and 125, 25 and 125. You're going to grab that table that I've asked you or reminded you to have throughout this time, and find which row has a 25 and a 125. And you'll notice that 25 is the same as 5 squared, and 125 is the same as 5 to the third. So I've replaced 25 and 125, and behind it in parentheses, I'll write down any part of the exponent. Now the 5 on both sides get to be canceled, and I have 2 times the quantity, x plus 3, and 3 times the quantity, x plus 1. 2x plus 6, 3x plus 3. You get to move the x's to the left or right. It's your choice. I'm going to move them to the right. And the answer is, we're asked to solve this problem for x, and then it does say to round our final answer to the nearest hundredth. So I know I want to get x by itself. I'm going to start by subtracting 4. You're welcome to watch this problem. I will provide us 1 or 2 problems after this, very similar for you to practice. So I'm going to subtract 4 from both sides. 3 raised to the 2x equals 21. Now, if you recall, I've said it multiple times during this unit, the only reason we truly have to learn about logs is because we're unable to solve for a variable that's in an exponent position without it. So you may remember that, but you're like, but how do I use logs? Well, ideally, we want to get rid of the 3. If we get rid of the 3, then we know what to do. We just divide by 2. So I'm going to take whatever that base is and write log base that number on both sides. Whatever you do to one side, you must do to the other. If this looks real messy for you, let me rewrite it. Now, on the right-hand side, the reason we do that is this base 3 and this 3, it's going to simplify to 1, and I get to bring down whatever was there. And my last step is to take whatever this quantity is, which I can figure out in the desmos calculator, and if I want to isolate the x, I'm going to divide by 2. I'm going to take whatever this quantity is and then divide it by 2. Okay, now I already know it says I'm going to round to the nearest hundredth, which means anytime I round, I'm going to use that symbol. How do I plug this in and get an answer? Okay, we'll do that next. So I'm going to come over to desmos. I'm going to clear this out, and I'm going to start with a parenthesis. Then I'm going to go to functions, miscellaneous, log base. Remember, it was log base 3. I used the arrows to get inside, 21. And then I'm going to, okay, so that's the top. Notice I put parentheses here and parentheses here. That's the top of the numerator, and then I'm going to divide it by 2. And again, this happens to be, it says round to the nearest hundredth. So 1.3, now does it stay as an 8 or does it round up? Because the number behind the 8 is a 5, it rounds up. Very similar problem, asking you to do the same thing. You're going to solve for x and round your final answer to the nearest hundredth. Now, if you felt real confident watching that last problem, I'd like you to write this down, press pause and do it yourself, then press the play button on the video and you'll be able to see me work through it. If you still are feeling a little uneasy with that last problem, please do this problem with me. You can just watch if you'd like. We'll do one problem after this again that you can attempt on your own. If I'm solving for x, I'm going to get rid of 4 first. And like I said in the last video, the only reason we learn logs is so that we can solve for a variable in the exponent position. 5, this is what I want to get rid of. So to get rid of it, I take log base 5 on both sides. And the purpose of that, then on the right-hand side, log base 5 and 5, is it simplifies to 1, and I get to bring this down. So could I put a 1 in front? Sure, but I know 1 times 3x is just still 3x. So you could put a 1, that would be fine. But we know 1 times 3x, again, is just 3x. And then the last step to solve for x is going to be divide by 3. Now, although this is great, how you plug it in matters. So I'm going to come back to desmos, and I'm going to act as if we didn't have that, so we can practice again. Again, this is how it looks when you just start desmos. So I come up here, come down to the keyboard, type functions, make sure miscellaneous is checked, and log base A. Now, I'm going to first start by, oh, I forgot to do this. I want to start by putting a parenthesis in before I even get started. So function, log base A. The base of this particular problem is 5. I use the arrows to get inside of there. 48, and now I go behind it with two ending parentheses. Now this particular problem is going to have a denominator of 3. And now to round this to the nearest hundredth, it's going to be 0.8. Now is it just 80 or is it 81? Does it round up? So I go to the second place, think about that, and I look behind it. It says stay the same. So this particular answer would be approximately 0.80. I'm going to have everyone try this on your own. Please write down 6 raised to the 2x plus 2 equals 51. Please begin on your own. I will solve this at the same time you are, but I will do it without explaining my answer. So if you're somebody who's struggling, you can just watch. But the goal is for everybody to be trying it on your own at this time. We're going to do 2 problems, and for both problems we're going to use the same equation. So this represents the total amount of money you have after a certain period of time in years. And this means what is your initial investment. Remember, E is a numerical value. It stands for Euler's number. It's a numerical value. It's not a variable. So we're going to do this twice. The first time we're going to say we invest $500. We want to know how long will it take for that $500 when invested in earning interest to raise up to $1,200. How long does it have to sit in the bank without you taking money out of it or adding to it? Or maybe it's an investment in stock, but how much does it have to, how long a time does it have to sit there? So I start by taking that initial problem, and I'm going to put in 1,200. That's the final amount we want. We start with 500, and remember this is a numerical value. So I'm going to start by dividing both sides by 500. Now 500 on the left, 500 on the right. Whatever you do to one side, you must do to the other. You don't have to simplify this, but if you didn't know this, when you have zeros on the back end and it's a numerator divided by a denominator, you can simply cancel them out. So 1,200 over 500 does automatically simplify to 12 over 5. It's not necessary. If you didn't do that, you'll still get the same final answer. Okay, so how do we get rid of this E? Because eventually I want to take the T down. So to do that, I'm going to take log base E on both sides. Log base E, whatever you do to one side, you must also do it to the other side. Why did I choose a log base E? Because this is the number I'm trying to get rid of. And then on the right-hand side, it doesn't just disappear, it really simplifies to a 1. So I could bring down a 1, but I know 1 times this quantity. It's not going to change anything. Okay, and my final step is to solve for T. It does ask us to put our final answer and round it to the nearest, let me go back, nearest thousandth. So we'll talk about thousandths is just like hundredth is just one place more. Okay, how we plug this in matters. I'm going to put a parenthesis around this whole thing, and then I'll divide by the bottom. Okay, so here we go. I'm going to do the top and then divide by the bottom. Log base E of 12 over 5 divided by 0.12. Okay, so I start by doing a parenthesis first. Then I go over to functions, make sure miscellaneous is highlighted, and log base A. This is going to be the numerical value E. 12 divided by 5. Oops, excuse me. I got to put that in parentheses. 12. Let's start again. This has got ugly. My apologies. Parenthesis, function, log base A. Now this is an E. I go inside using the arrows to get inside. It's 12 divided by 5. and then I use arrows to get back out, and I'm going to do two end parentheses. One parenthesis to end the fraction, one parenthesis to end the numerator. And now it's divided by 0.12. What does this mean? Okay, I got to write this down. 7.29557, da da da. Okay. It asks us to round to the nearest thousands. Thousands is right here. I look behind it. The number behind it says stay the same or round up. 5 or above, we round up. So this answer is approximately 7.2. Okay, this rounds up 96 years. So if you invest, according to this, if you invest $500 and you never touch it and it grows at the same rate, in a little over 7 years, you'll be up to $1,200. Now keep in mind that for this, they don't want you just to write a little over 7 years. They actually want us to write down this answer and to put years behind it. We're going to do the same one. It will be our last problem of this review. Same concept. This is your total amount after T number of years. This is the initial investment. Remember, E is a numerical value. Now, this time, you're going to start by investing $400. You don't touch it, don't delete any money from that account, don't add to it, and how long does it take to get to 1,000? So I have 1,000 is the final amount, 400 is the initial investment, then it's E raised to 0.12, and we want to know what that time is. So I'm going to start by dividing both sides by 400. It is not necessary for you to reduce on the left. If you do it, or if you don't do it, you'll get the same answer in the end. I'm just doing it to make it look a little bit nicer here. So I have 10 over 4 equals E raised to 0.12t. I need to get rid of the E so this part can come down. So I'm going to do log base E on both sides. Log base E on both sides. Then I'm going to write what was already there, 10 over 4, and E to the 0.12t. On the right-hand side, it's going to simplify to a 1. I could write a 1 down. I know 1 times this quantity isn't going to change anything, so it's not necessary to put a 1 down. And then I'm going to divide by 0.12. Okay, it does, just like the last part, asks us to round to the nearest thousands. So I'm going to slowly put this in to make sure I don't make any mistakes. So I start with the parenthesis, function, miscellaneous, and log base A. E is our base. Use the arrow to get inside of the parenthesis. 10 divided by 4. Use the arrow to now end both, I got to see here, both end that fraction and end the numerator, and then I'm going to divide it by 0.12. What does this look like? So 6.950. Behind the 0 is a 3, so I'm not going to round it up. Then what does this mean? It means for this problem, if we assume this is correct, that it rises, your bank account rises at this rate, we can assume that it goes from $400 to $1,000 in almost 7 years, 6.950 years.